Hey, I'm Noggs, and this is Noggs House. Today we are going to talk about the Cosmic Dark Ages. The Cosmic Dark Ages started about 380,000 years after the Big Bang. This might sound like a long time, but in universe time, it's actually pretty early. Before this, the universe was super hot plasma. That's like a soup made of tiny particles called protons and electrons all mixed together. These particles kept bouncing light around so you couldn't see through it, kind of like trying to look through a really thick fog. But once the universe cooled down to about 3,000 degrees Kelvin, that's still crazy hot, about 5,000 degrees Fahrenheit, something important happened. The protons and electrons stuck together to make hydrogen atoms. When this happened, light could finally travel freely for the first time. This moment is called recombination. That means things combining again, or photon decoupling. Photons are particles of light, and decoupling means they stopped getting stuck. This created the cosmic microwave background radiation we talked about last time. But here's the thing. Once electrons were locked inside atoms, there were no more light sources. The universe went completely dark. It was filled with a thick cloud of neutral hydrogen gas. Neutral means the atoms weren't charged, just sitting there in the darkness waiting for something to happen. After the Dark Ages began, the universe kept cooling down. Think of it like leaving a cup of hot chocolate on the counter. It just keeps getting cooler over time. At the start of the Dark Ages, the temperature was around 4,000 degrees Kelvin. But as millions of years passed and the universe kept expanding, the temperature dropped all the way down to about 60 Kelvin. That's around negative 213 degrees Celsius. Way colder than any freezer. The main reason for this cooling was the expansion itself. Remember how space is stretching? Well, as space stretched, those photons from the cosmic microwave background got stretched too. When light gets stretched, it loses energy and becomes cooler. The photons went from being visible light to infrared light, that's heat you can't see with your eyes, to microwave radiation, like what heats up your food in a microwave oven. This cooling was really important because it set up the conditions needed for the next big thing to happen, the first stars. Even though the Dark Ages seem boring, just darkness and cooling, something really important was happening behind the scenes. Gravity was slowly getting to work. The universe was mostly filled with hydrogen gas spread out everywhere. But remember those tiny ripples we talked about from cosmic inflation? Those were still there, creating spots where the gas was just a little bit denser. Denser means packed more tightly than other spots. Gravity is a force that pulls things together, and it started pulling on these denser areas. Slowly, bit by bit, more hydrogen gas got pulled into these spots. It's like how a snowball rolling downhill picks up more snow and gets bigger. These clumps of gas would eventually become the places where the first stars were born. The gas floating around the Dark Ages was really different from what we see in space today. We call it primordial gas. Primordial means from the very beginning. This gas was super simple. It was almost entirely just hydrogen and helium, the two lightest elements. Elements are the basic types of matter. There were also tiny amounts of lithium. That's it. There were basically none of the heavier elements that we call metals in astronomy. Things like carbon, nitrogen, oxygen, or iron. Now you might think, why does that matter? Well, it matters a lot. In the universe today, when gas clouds want to collapse and make stars, those heavier elements help the gas cool down. They work like coolants in a car. They help get rid of heat. Without these heavier elements, making the first stars was much harder. The primordial gas had to find a different way to cool down so it could collapse under gravity's pull. So how did the primordial gas manage to collapse and make stars without those helpful heavy elements? It needed some special tricks. For a gas cloud to collapse and make a star, it has to cool down. When gas gets squeezed together, it heats up, like when you pump up a bike tire and it gets warm. So the gas needs a way to get rid of that heat. Without heavy elements to help, the universe had to use molecular hydrogen, which we write as H2. That's when two hydrogen atoms stick together to make one molecule. These H2 molecules could wiggle and spin in ways that release energy, helping the gas cool down to about 200 degrees Kelvin. Sometimes if there was something called hydrogen deuteride, HD, that's hydrogen mixed with a special heavy version of hydrogen called deuterium, the gas could cool even more. This cooling happened in special places called mini-halos. These were clumps of dark matter, mysterious invisible stuff that we can't see but that has gravity, that weighed about 100,000 to 1 million times as much as our sun. In the very densest parts, the gas became fully molecular, meaning it was all H2 molecules instead of single atoms. And that's where the first stars would finally form. When the first stars finally turned on, they were absolutely incredible and totally different from stars today. Scientists call them population 3 stars. That's just a naming system astronomers use. Population 3 came first, population 2 came second, and population 1, which includes our sun, came third. These first stars were monsters. They were probably hundreds of times more massive than our sun. Some scientists think there might have been even supergiant stars 1 million times the mass of the sun and 1 billion times brighter. These stars were incredibly hot, with surface temperatures between 20,000 and 100,000 Kelvin, way hotter than our own sun's 5,800 Kelvin surface temperature. Because they were so massive, they burned through their fuel super fast, like a race car that guzzles gas. They only lived for a few million years. Our sun will live about 10 billion years. So these stars were like shooting stars in comparison. Even though they were short-lived, they pumped out enormous amount of ultraviolet light, UV light. That's the light that gives you sunburn. This light was about to change the universe forever. Even though population 3 stars had short lives, they did something super important for the universe. They made the first heavy metals. Inside their incredibly hot cores, these stars were like giant factories. Through nuclear fusion, that means smashing atoms together to make new ones, they took simple hydrogen and helium and created heavier elements like carbon, oxygen, and iron. When these massive stars ran out of fuel, many of them exploded in what we call pair instability supernova. These were enormous explosions, even bigger than regular supernovas. A supernova is when a star explodes at the end of its life. These explosions scattered all those newly made heavy elements out into space, mixing them into the pristine gas around them. Pristine means pure and untouched. This was huge. It meant the next generations of stars could form gas that had these heavier elements. Without population 3 stars making these elements, we wouldn't have the rocky planets, the water, or even the carbon-based life that exists today. They literally made the ingredients for everything. The population 3 stars didn't just make heavy elements, they also ended the Dark Ages. Their intense ultraviolet light was powerful enough to do something called reionization. Remember how electrons had combined with protons to make neutral hydrogen atoms? And that's what started the Dark Ages? Well, the UV light from these first stars was so strong that it started ripping those electrons back off the atoms. When you strip an electron away from an atom, you're ionizing it. Ionizing means making it electrically charged again. As more and more stars formed, they created bubbles of ionized gas around them. These bubbles grew and merged together, kind of like soap bubbles combining. This process cleared away the thick fog of neutral hydrogen that filled the universe. Scientists think reionization started about 680 million years after the Big Bang and was mostly finished by about 1.1 billion years after it. This transformed the universe from dark and foggy to clear and bright. Finally, light could travel freely across space again. The Dark Ages were over and the universe entered a new era of light. You might be wondering, if scientists know so much about population 3 stars, why haven't we seen pictures of them? It's actually super hard to spot these first stars even with our best telescopes. There are a few reasons why. First, they're incredibly far away in both distance and time. The light from these stars has been traveling for over 13 billion years to reach us. Second, because the universe has been expanding this whole time, that light has been stretched a lot. We call this redshift. The light started out as ultraviolet and visible light, but by the time it reaches us, it's been stretched all the way into infrared light. That's heat radiation we can't see with our eyes. This makes them extremely faint and hard to detect. The James Webb Telescope launched in 2021 and is specially designed to see infrared light. It's like having super powerful night vision goggles for looking at the early universe. Scientists are using the telescope to search for these first stars. Sometimes they use a trick called gravitational lensing, where a massive galaxy cluster acts like a magnifying glass, bending and brightening the light from the objects behind it. We might not be able to see individual population 3 stars easily, but the telescope might detect their combined glow or maybe even a few lucky examples. Thanks so much for joining me today at Nog's House. We've traveled through the cosmic dark ages, that long period when the universe was just cooling down and waiting. We watched as gravity slowly pulled gas together, and then we saw the amazing moment when the first stars finally lit up. These population 3 stars were incredible giants that lived fast and died young, but they changed everything. They made the first heavy elements that would become planets and eventually us, and their light cleared away the cosmic fog, ending the Dark Ages forever. Next time we're going to talk about something called stellar alchemy, and how stars make all the different elements. It's like cosmic cooking. I hope you'll come back and hang out with me for that. See you next time at Nog's house.